Section 1.4, we're talking congruent figures. Objective today is to recognize congruent figures and their corresponding parts. Okay, so as far as congruent figures go, we're talking congruent polygons. I'm going to say they're polygons with congruent corresponding parts. And when I say corresponding parts, we mean the matching sides and angles. Alright, so I'd say that these two polygons here are congruent to each other. And we'd say that ABCD is congruent to EFGH because basically they're the same size and same shape. Okay, what makes them the same size and same shape is that their corresponding parts are all congruent to each other. So for example, AB and EF are congruent here. They're the same length. Okay, each of those side lengths will be the same. Same thing with the angles. Angle B is congruent to angle F. Okay, so each of our sets of angles are congruent. That's what makes these polygons congruent. Alright, problem 1, finding congruent parts. It says that if polygon HIJK is congruent to polygon LMNO, what are the congruent corresponding parts? So as in which sides and which angles match up congruent to each other. Okay, we want to list them all. I can start off with side KJ. And I know that's going to be congruent to the corresponding side, ON. And notice as I name those, I matched up corresponding angles. K and O look like they're the same size. J and N do as well. You do the same thing for JI and NM. You can say segment JI is congruent to segment NM. We can do the same thing for HI and LM. And also HK and LO. Alright, those are my angles, or sorry, my side lengths, and we also want to do the angles. We can say angle K is congruent to angle O. We can say that J is congruent to N. We can say I is congruent to M. And finally, angle H and L will be congruent as well. Alright, so we can match up those congruent corresponding parts from the picture based on the fact we know these two polygons are congruent. And the trick is with this is when I'm given a congruent statement like this, I actually don't even need my picture. Notice that both H and L were the first angles named. And down here we have H and L congruent to each other. Alright, same thing, we have the segment JK and NO are both the last parts here. Okay, notice that KJ, ON are matching up. So anytime I make a congruent statement, I want my corresponding parts to match up in order. And when we're given a congruent statement, we can use that to figure out what the corresponding parts are, just based on the letters. In problem 2, we're using congruent parts. Part A says that triangle LMN is congruent to triangle PQR. We want to know what is the value of X. So we have two congruent triangles and some different expressions. Now the trick for this one is going to be matching up the correct corresponding parts and making an equation out of them. Now notice here MN corresponds with QR. And I know an expression for MN, but I don't know anything for QR, so I can't use that 12. Same thing, PQ corresponds with LM, which I don't know, so I can't make an equation there. What I need to use is the LN and the PR because I have expressions for both those parts. Okay, I can confirm up here, L and N are the first and then third letters. P and R are the same thing for our second figure, in case we know these two correspond. Since they correspond, we know these side lengths are congruent. So the equation I can set up then is just 10 is equal to 2x plus 4. Alright, solving that, subtract 4 from both sides, we end up with 6 is equal to 2x, and divide both sides by 2, we end up with x equals 3. Alright, so x equals 3, based on the fact that these two triangles are congruent to each other. Problem B is the same idea. I want you to take a second, pause the video, work through that problem, and then hit play to check your answers. The last thing we're going to talk about quickly is something called the third angle theorem. It says that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So as in, if I have two triangles, okay, they don't need to be the same size, but just have angles congruent, and angle A is congruent to angle D, and B is congruent to angle E, we have two angles congruent. That means we get the third angles for free. The third angles have to be congruent as well. Okay, reason for that is both these triangles' angles will sum to 180, and if I subtract the same amount from 180, I'll get the same thing for the two remaining angles. So this last problem is going to utilize that third angle theorem. Okay, problem 3, finding congruent triangles. It asks, are the triangles congruent? Justify your answer. Now if we want to prove these two triangles congruent to each other, what I need to do is I need to show that all of their corresponding parts, their sides and angles, are congruent. Okay, so let's start listing those off. We know that AB is congruent to ED, okay, because they're marked congruent to each other. By the same token, we know that BC is congruent to DC, because they're labeled with the same measurement. And also that AC is congruent to EC. Then I'm also given one of my angles. I'm given that angle A is congruent to angle E. And how do we know all that? Well, that is all given to us in the picture. Yes, we've got all three sides right off the bat and one out of the three angles. Okay, what we need to do next is figure out if the other angles are congruent. Okay, I'm going to say that they are. In the middle, I have a pair of vertical angles, and we know that vertical angles are congruent. So I can say that angle ACB is congruent to angle ECD, okay, because they're vertical. Alright, now once I have two triangles with two angles congruent, I know the third angle is congruent basically for free, and that's based on our third angle theorem. We could say that angle B is congruent to angle D, again by the third angle theorem. Alright, so all the corresponding parts match up and are congruent. Therefore, the triangles are congruent. So answer to this question, I can say yes, triangle ABC is congruent to triangle, and then I need to name that in the same order. Okay, A matches with the E, so we'll say triangle E. B matches with D, so the D next, and then they both come together at C. So we can say yes, triangle ABC is congruent to triangle EDC.